Students, success. In the last video we have discussed introduction to matrices and what are the types of matrices. Today in this video I'm going to discuss very important topic, that is echelon form. But before knowing this echelon form, we should have an idea about row elementary operations. Then I will explain the concept of echelon form. Okay, now let's start the class.
It is very important to know what are elementary transformations. Elementary transformations are of two types. First one is row elementary transformation and second one is column elementary transformation. Again, this row elementary and column elementary transformations are of three types. The first one is interchanging of two rows or columns. We call it as row swapping or column swapping. That is, we have to interchange any two rows or any two columns. I'll explain here. See children. That means Ri can be swapped with Rj. And coming to the column, Ci can be swapped with Cj. For example, R1 can be swapped with R2 and R2 can be swapped with R3 and R3 can be swapped with R1. In the same way, coming to the column 1 can be swapped with column 2. Column 2 can be swapped with column 3 and column 3 can be swapped with column 1. So this is what is called as interchanging any two rows or columns. Now coming to the second step, multiplying each element of a row or a column with a non-zero scalar. We call it as row scaling or column scaling. That is, we have to multiply each element of a particular row or a particular column with a scalar factor. I will explain this. See here students. Ri implies the scalar factor is represented as k into Ri. Okay, in coming to this column, Ci implies k into Ci. For example, R1, that is first row, I am multiplying with a scalar factor as 2 into R1. That is, all the elements of first row are multiplied by 2. In the same way, all the elements of first column are multiplied with 3. This is how the row scaling or column scaling takes place. Now coming to the third step, adding the above step to the corresponding elements of jth row or column. We call it as a row replacement or column replacement. That means we have to add step B and step C. Whatever the scalar factor that is obtained in step B, we will add that scalar factor to the jth row of step C. Let me explain. It means that Rj, jth row, right? Rj implies Rj plus what is the scalar factor in the above step, that is Kri. Now add this Kri here. Now coming to the column, Cj implies Cj plus what is the scalar factor in the above step for column? It is Kci. Now add that Kci here. Kci. Okay, for example, if I tell you R2 implies R2 plus what is the scalar factor in the above step? We have taken, for example, 2R1. Now add this 2R1 to R2. Now coming to the column, C2 implies C2 plus what is the scalar factor in the above step? It is 3C1. Now add this 3C1 here, 3C1. Okay, so there will be a change in the second row elements and second column elements. So these are the three steps for elementary operations. Now I will explain all these three steps with an example. Here is the matrix 520 731 minus 489. The first step is row swapping. I will swap, for example, R1 with R2. I am swapping R1 with R2. You can swap any two rows. That is not a problem. Here I am explaining row elementary transformation now with this example. You can same do with the column elementary transformation. Okay. So when I swap this R1 and R2, the matrix will look like 7, 3, 1. The second row becomes the first row now and the first row becomes the second row and there will be no change in the third row. So this is how the matrix look after the row swapping. Now row scaling, that means we have to multiply the elements of a particular row with a scalar factor. For example, I am taking second row. Okay, I'm multiplying with a scalar factor 2 into R2. Okay, see here students. R2 implies 2 into R2. So, okay, what is the first element of R2? It is 5. So, 2 into 5, which is nothing but 10. Now, what is the second element of R2? 2 into 2, 4. And the last element of R2 is 0. So, 2 into 0, 0. So, now what are the new elements of R2? 10, 4 and 0. Now we are going to write those. The first row and the third row remains the same. 7, 3, 1. There will be a change in the second row elements. That is 10, 4, 0, minus 4, 8 and 9. So this is how the matrix look after the row scaling. And coming to the last step, that is row replacement. Row replacement. That means, for example, again I am taking first one. R1 implies R1 plus, what is the scalar factor that we have taken in step 2? 2R2. Now I will add this 2R2 here. Okay, there will be a change in the first row elements now. Now see here students, R1 implies R1 plus 2R2. What is the first element in R1? 7 plus 2 into first element in R2 is 10. That is 2 plus 20, which is nothing but 27. Now, in the same way, what is the first element in R1? 3 plus 2 into second element in R2 is 4. So, this is 3 plus 8, 11. Now, what is the third element in R1? It is 1 plus 2 into third element in R2 is 0. So, it is nothing but 1. So, now what are the new elements of first row? 27, 11 and 1. Now I will replace the first row with these new elements and the second row and third row remains the same. So what are the elements that I got? 27, 11 and 1. So 10, 4, 0, minus 4, 8 and 9. This is the final matrix after the 3 steps: row swapping, row scaling and row replacement. Here you have to make a note, students, that there is no compulsory that you have to maintain this order. Okay, yeah, you can first perform row replacement, then you can perform row swapping or row scaling, or first you can perform row swapping, then comes row replacement. Depending upon the type of problem, the order may change. It is not compulsory that you have to maintain this order. Clear, students? Next, let's go to the next topic, that is rank of a matrix. The rank of a matrix is defined as the order of square matrix whose determinant is not equal to 0. So what is the condition here? Determinant should not be equal to 0. For example, for a 3 by 3 matrix, if determinant is not equal to 0, then rank of A is equal to order, which is nothing but 3. Here we have taken 3 by 3 matrix, right? So the rank is nothing but order, that is 3. But if determinant is equal to 0, then the rank of matrix A is less than order. It means the rank of A is less than 3. What does it mean? It means that the rank of A can be either 2 or the rank of A can be 1. So when can be the rank is equal to 2 or 1? When the determinant is equal to 0. Clear? That is what I have explained here. Rank of A is equal to order of the matrix if determinant is not equal to 0. But if determinant is equal to 0, then the rank becomes less than the order of the given matrix. I will explain you with an example here. Here is the example: 1, 2, 3, 2, 3, 4 and 0, 1, 2. See here, student. Here we will find determinant A is equal to. So here it is plus, minus and plus. Okay. 1 into, we have to see the corresponding row and corresponding column. So what are the elements that are left here? It is 6 minus 4. Okay, so minus 2 into corresponding row, corresponding column, that is 4 minus 0, plus 3 into. So again see the corresponding row and corresponding column. We are left with 2 minus 0. 2 minus 0. So this is equal to 1 into 2 minus 2 into 4 plus 3 into 2, which is nothing but 2 minus 8 plus 6 minus 6 plus 6 is equal to 0. Now the determinant is equal to 0. So the rank of the matrix will be less than the order. That is, it will be less than 3 by 3 matrix, right? So the rank of the matrix will be less than 3. Okay. For that we have to take a take a 2 by 2 minor matrix. 2 by 2 minor matrix. That is, I will take any 2 by 2 minor matrix. I am taking 1, 2, 2, 3. Okay, 1, 2, 2, 3. So what is the determinant now? This into this minus this into this, right? So determinant A is equal to 3 minus 4, which is nothing but minus 1. And this minus 1 is not equal to 0. Therefore, now what is the rank of the matrix? The rank of the matrix is equal to 2, because for a 2 by 2 minor matrix, we got the determinant not equal to 0. Okay, students. Now let's see the two important terms, that is zero row and non-zero row. If all the elements of a row are 0, then it is called a zero row. All elements of a particular row should be 0. For example, I am taking here an example. Okay, 1, 2, 3, 4, 5, 0, 0, 0, 0. So this is the matrix I have taken. For example, okay, this is R1, R2 and R3. If you see carefully, the third row, all the elements of third row are 0. So we can say that R3 is a 0 row. Now, non-zero row. If all the elements of a row are not 0, then it is called non-zero row. All the elements should not be 0. That is called a non-zero row. Here R1 and R2, all the elements are not 0. In coming to R1, we have 1, 2, 3. But whereas coming to R2, we have 4, 5, 0. But all the elements are not 0. Only one element is 0 here. So we can say that R1 and R2 are non-zero rows. Clear, students? Non-zero rows. Next, coming to the methods to find the rank of a matrix. Here, whatever the matrix we have seen, this method is based on the determinant of a matrix. The rank of a matrix will be based on the determinant here. But whereas coming to this, there are two methods to find the rank of a matrix. First one is echelon form and triangular form. And the second one is normal form. Echelon form is also called as triangular form. Okay, first let's discuss echelon form of a matrix. A matrix is said to be in echelon form if it has the following properties. First one, listen carefully, students. Zero rows are below any non-zero rows. It means that 0 rows should be below any non-zero rows. See, coming to the example here, this is R1, R2, R3 and R4. Okay. Now R4 is completely a 0 row because all the elements are 0. And R1, R2, R3 are non-zero rows because all the elements are not 0 here. Okay. So according to the first point, 0 rows should be below any non-zero rows. So R4 is below R1, R2 and R3. So the first step is satisfied, right? Clear, students? Next, the first non-zero entry in each non-zero row is equal to 1. What does it mean? What does it mean is the first entry in each non-zero row. What are the non-zero rows? R1, R2 and R3 are the non-zero rows and each entry should be 1. Okay. So here it is 1. If you can see, here it is 1 for row R1 and here it is 1 for R2 and here it is 1 for R3. Clear? The first non-zero entry in each non-zero row is equal to 1. Now, the third point is the number of zeros. Listen carefully this point. The number of zeros before the first non-zero element. The number of zeros before the first non-zero element of a row is less than the number of zeros in the next row. I will simplify this sentence, students. See the first row. In first row, what is the non-zero element? In first row, what is the non-zero element? Non-zero element is first 1. Before this one, we don't have any zeros. So forget about R1. Coming to R2, what is the non-zero element? It is 1. Okay. So before 1, we have 1 0 here. If you can observe carefully, before this non-zero element 1, we have 1 0. Now coming to R3, before non-zero element, what is non-zero element in R3? It is 1. And before 1, we have 2 zeros here. We have 2 zeros here. So what does it mean? That R2 has 1 0, R3 has 2 zeros. That is R2 is the number of zeros in R2 is less than the number of zeros of the next row, that is R3. So this is what is actually the third condition. R2 is less than R3. And the number of zeros should keep on increasing row by row. R2 has 1 0. Okay, R2 has 1 0. R3 has 2 zeros. And R4 has 3 zeros. Okay, the number of zeros are increasing row by row. So these are the 3 conditions that should be satisfied while solving the problems also. But here you have to remember one thing, that the condition 2 is optional. The condition 2 is optional. That is, it is not compulsory that the first non-zero entry should be 1. It is not compulsory. It can be any other number. If possible, make it 1 or else you can leave it. I will tell you this one. It means that R1, sorry, yeah. A11 is equal to A22 is equal to A33 is equal to A44 is equal to 1. Actually, the meaning of the second step is this one. But it is optional. It is not compulsory that these 4 elements should be 1. If it is possible, then you make it 1 or else you can leave it as it is, depending upon the problem. Then this point I will explain you while doing the problems. Clear, students? Now, the main important thing is, in echelon form, the rank of a matrix is equal to number of non-zero rows. Number of non-zero rows defines the rank of a matrix in echelon form. See, by seeing the example, see what are the What are the non-zero rows here? R1 is non-zero row, R2 and R3 are non-zero rows. So totally how many non-zero rows we have? 3 non-zero rows. So directly we can say that the rank of this matrix is 3. Simply. Okay, the number of non-zero rows is called the rank of a matrix in echelon form. And remember one thing, students, here make a note that in echelon form only row elementary transformations takes place, not column, in echelon form. Whereas coming to normal form, both row and column elementary transformation we are going to perform, but in echelon form only row elementary transformation we are going to perform. Clear, students, now? So these are the two important questions asked in the previous year question paper. Write row elementary transformations on a matrix. It is given in 2024 recent question paper. And next question is define rank of a matrix, and you have to explain the rank of a matrix with an example, and this is given in 2019. Mostly only row elementary transformation will be asked, not column. Only row elementary transformations will be asked. Very important questions. These two are very important questions. Simply define rank of a matrix, not echelon form of a matrix. This is the answer for the second question is this, rank of a matrix. Write down the definition like this. It can appear either for 2 marks or 1 mark, that's it. So write down the definition, take a simple example and find the rank of a matrix. And say that the condition has been satisfied. What is the condition? That rank is equal to order if determinant is not equal to 0. And rank is less than the order if determinant is equal to 0. Clear? For more videos and problems, please do subscribe Sankalp Study Success channel and download Sankalp Study Success app. In that app, we have lot of solved problems and also assignment questions which are very important, and those are from previous year question paper. So please do subscribe and download the app. Thank you, students.